Hello dear students. In the last lecture, the point where we stopped was regarding the methods of measurement. In the last lecture, we saw that we have two methods of measurement, direct method and indirect method. In direct method, the quantity which is to be measured is measured directly, which does not involve any calculations, whereas in case of indirect method we measure some another quantity. That quantity is then used in some form of expressions or equations, and then another quantity is determined. So the quantity which is to be found is not directly measured. That type of measurement method was termed as indirect type of method. So that is the point where we stopped. Now moving forward, when we talk about the measuring system, a measuring system is composed of 5 elements. These elements are standard, workpiece, instrument, person, and environment. Remember, previously in our previous lecture we have once discussed that for carrying out any measuring process there should be 3 elements, and here we are discussing about measuring system. That was measuring process. For carrying out any measurement process you need 3 elements. Those elements were a physical quantity which we termed as a measurand, the second element was a reference, and the third one was a comparator. That was regarding measurement process. This time we are discussing about measuring system. So any measuring system is made of 5 elements, and these elements are standard, workpiece, instrument, person, and environment. The most basic element of measurement is the standard, without which no measurement is possible. Once the standard is chosen, select a workpiece on which a measurement will be performed. Right now, if we go for a measurement process, we need some sort of systems. When we say that we need some measurement to be determined or a physical quantity to be determined, then that physical quantity needs to be measured in some standard, and that standard is the first or the very basic element of any measurement system, right? That may be the length, it may be angle, etc. in degrees, right? Now length in meters, etc. So that unit is termed as the standard, and that forms the basic of a measuring system. The second thing, when we say that we need a physical quantity to be determined in some standard, in some unit, then we are determining that physical quantity on some workpiece, right? Now we measure dimensions of something, some product, some workpiece. So the second element which we need is your workpiece. That is, we get that workpiece. The third element of measuring system is the instrument. To determine some physical quantity we need the instrument, so that instrument forms the third element of any measuring system. Secondly, that whole of the measurement process will be performed by some person, so there should be a person to do all these activities. And finally, it should be well defined that under which conditions the measuring procedure is to be taken. So that is the environment. A proper environment should be well defined. So these are the 5 elements of any measuring system. Suppose we take an example that I have an industry, and in that industry some product is manufactured. I have to determine the thickness of that product. Now what I will do, I know that since the thickness is to be measured in terms of mm, so that mm forms the standard. Secondly, the product which is to be whose thickness is measured, that is the workpiece. So the workpiece is the second element. I need to determine its thickness, so that thickness in mm is the standard. I have the workpiece. I will take an instrument, say for example a micrometer. I will take a micrometer to determine its thickness, so that micrometer is the instrument, which is the third element. Then the person or myself will be performing or will be measuring that thickness. And finally, say I need a proper temperature and air controlled room to carry out this measurement. So that is the environment, which is the fifth element of measuring system, right? Now moving forward, let us see some of the terminologies which we will require in our further course to be discussed. The very first terminology is accuracy. Now, when we define accuracy, accuracy is defined as the closeness of the measured value with true value. Remember, whenever designer designs some product, he intends some specific dimension of that product. Now, the dimension set by the designer is the true value. Now, we also know that since any manufacturing process cannot give me exact dimension, that is true dimensions, there will be some variations. Now, after manufacturing that product, when the dimensions are measured, it will vary from the specified dimensions of the designer. Now, the measured dimensions, which is how much close, its closeness to the true dimensions which is set by the designer, is termed as accuracy. Say for example that we have to measure thickness of some steel plate. Now the designer says that steel plate should have 10 mm thickness after manufacturing it. Now after manufacturing, if we find that it is not manufactured of exactly 10 mm, it is being manufactured at 9 mm, 9.5 mm, the second plate 9.7 mm. So we have three different dimensions, 9 mm, 9.5 mm, 9.7 mm. Now we can say that the plate with thickness 9.7 mm is more accurate, right? So we can say that accuracy is nothing but it is the closeness of the measured value with true value, right? Or we have another definition as accuracy is defined as the degree to which measured value agrees with the true value. How much close the measured value is with respect to the desired value is nothing but accuracy, right? Now this is the thing which we have discussed, that practically it is very difficult to measure the true value, and therefore a set of observations is made whose mean value is taken as the true value of quantity measured. So in that case we measure the term accuracy and define it, that how much accurate the product has been manufactured. Now secondly, the second term is precision. Generally students get confused between these two terminologies, accuracy and precision. So how we have defined accuracy as the closeness, the degree of closeness of the measured value with respect to the true value, right? Now second term is your precision. The precision is specified as the measure of how close repeated trials are to each other, or the closeness of repeated measurements. Suppose for example I manufacture a steel plate in my industry and we have a mass production. Now the dimensions or the thickness of each product should be varying by very small amount. That is precision. In that case we can term it as a precise one. अगर हम कहें कि हमारे हर एक प्रोडक्ट मेजर करने के बाद हमें सेम वैल्यू मिलती है, तो हम कहेंगे कि हमारा मेजरमेंट ये प्रिसाइज्ड है, राइट? इट डजंट हैव टू डू एनीथिंग विथ एक्यूरेसी. मान लीजिए हम एग्जांपल लेते हैं कि हमें एक स्टील प्लेट को मैन्युफैक्चर करें, हमारे पास एक 10 स्टील प्लेट है, 10 प्लेट स्टील प्लेट्स में से अगर हम 10 स्टील प्लेट की मेजरमेंट कैरी आउट करते हैं, हमारा डिजायर्ड वैल्यू हमने जो पिछले एग्जांपल में लिया था, लेट इट बी 10 mm, हमारे पास 10 स्टील प्लेट्स हैं, हमारा डिजायर्ड वैल्यू है कि उनकी थिकनेस 10 mm होनी चाहिए। नाउ जब हम मेजर करते हैं तो से हम कहेंगे कि हमारे पास स्टील प्लेट नंबर 1 जो है उसका डायमेंशन कुछ 9.5 mm मिलता है, प्लेट नंबर 2 जो है उसका डायमेंशन 9.7 mm मिलता है, प्लेट नंबर 3 9.52 मिलता है, प्लेट नंबर 4 9.4 मिलता है, प्लेट नंबर 5 9.53 मिलता है। सो हम कह सकते हैं कि ये जो पहले 5 प्लेट मिले हैं ये एक्यूरेट है सिंस 10 mm के पास में है, और प्रिसाइज भी है क्योंकि हमने पांचों प्लेट के जो डायमेंशंस लिए हैं वो 9.5 mm के आसपास ही मिले हैं, वो एक दूसरे के बहुत पास हैं, उनके डायमेंशंस बहुत पास हैं, सो ये प्रिसाइज भी है। अब अगर हम कहेंगे कि प्लेट नंबर 6 है उसका डायमेंशन कुछ हमें मिलता है 6.5, प्लेट नंबर 7 का डायमेंशन हमें 6.8 मिलता है, प्लेट नंबर 5 का प्लेट नंबर 8 का हमें 6.4 मिलता है, प्लेट नंबर 9 का 6.3 मिलता है। तो अब हम कह सकते हैं कि हमारे जो मेजर डायमेंशंस ऑफ प्लेट नंबर 6, 7, 8 और 9 हैं वो प्रिसाइज हैं क्योंकि उनके वैल्यूज मेजर जो हैं वो 6.5 के बहुत पास हैं, लेकिन हमें डिजायर्ड थिकनेस था वो 10 mm था, मतलब कि प्लेट नंबर 6, 7, 8, 9 के जो थिकनेस हमने मेजर किए हैं वो एक्यूरेट नहीं है लेकिन वो प्रिसाइज है। तो लेट मी से कि प्रिसीजन इज नथिंग बट द क्लोजनेस ऑफ रिपीटेड वैल्यू, रिपीटेड वैल्यू कितना एक दूसरे के क्लोज है, कितना एक दूसरे को रिपीट करते हैं, दैट इज टर्म्ड एज प्रिसीजन। Precision can also be defined as the repeatability of measuring process. It refers to group of measurements for the same characteristic taken under identical conditions. एक ही आइडेंटिकल कंडीशन में, सेम कंडीशन में अगर हम बहुत सारे रीडिंग्स लेते हैं और सेम ही प्रोडक्ट के लेते हैं तो हमें बार बार तो सेम रीडिंग मिलने चाहिए, तो उस केस में हम कहेंगे कि दैट इज प्रिसीजन। Right? If the instrument is not precise, it will give different results for the same dimensions with measured again and again. अच्छा भाई, अब सिंस हमने कहा कि this both terminologies are a bit of confusing one, that is precision and accuracy. Students always get confused between precision and accuracy. Let us understand it with the help of some example. Now मान लीजिए कि हमारे पास एक बोर्ड है जहां हमें एरो मार्किंग करनी है। नाउ रिमेंबर जो हमारा पहला केस दिख रहा है यहाँ, हियर ऑल द एरोस आर मार्क्ड एट अ स्पेसिफिक पॉइंट, है ना, और जो हमारा ये जो रेड मार्क है, दैट रेड मार्क वाज द बुल्सआई वेयर द एरोज हैज टू बी स्ट्रक। नाउ क्या हम कह सकते हैं कि तीनों के तीनों एरो इन द फर्स्ट केस, ये जो तीनों एरो हैं, तीनों एरो एक ही जगह पे लगे हैं, मतलब कि एक्यूरेट हैं, लेकिन तीनों भी एक ही जगह लगे हैं तो वो प्रिसाइज हैं। अब हम सेकंड केस देखते हैं। सेकंड केस में हम कह सकते हैं कि नाइदर इट इज एक्यूरेट नॉर प्रिसाइज वन। इन द थर्ड केस एक्यूरेट नहीं है, सिंस हमारा जो डिजायर्ड स्पेस था वो तो हमें यहाँ हिट करना था, लेकिन एक्यूरेट नहीं है, लेकिन तीनों के तीनों एक ही जगह पे लगे हैं, तो दैट इज अ प्रिसाइज वन। अब हम फोर्थ केस ले सकते हैं कि दैट इज नथिंग बट एन नाइदर एक्यूरेट नॉर प्रिसाइज। सो दिस इज हाउ वी कैन अंडरस्टैंड accuracy and precision. In case A, I have given the description also. In case A, the three dots hit the target center and are very close together, so they are very high accuracy and high precise one. In case B, the three dots hit the target center but are not very close together, so that is high precise one, but actually they have a very low precision. Another term, in the third case here, in this case the three dots, that is our arrows, they hit very near to each other, they do not hit the target center but are very close together. So we can say that they have low accuracy and high precision. And the very last one, in this case, we can say that the three darts do not hit the center target and are not close together. So they have a low accuracy and precision. So that is what we are talking about, accuracy and precision. Now, let us talk something about the factors which affect the accuracy of any measuring system. Remember what we said, that accuracy is nothing but how much nearer value is measured to the desired value, right? Now, the measuring instrument should be very accurate. He should measure the accuracy of the physical quantity very accurately. Now, there are certain factors which affect the accuracy of any measuring system. Let us talk about these factors. The basic components of any accuracy evolutions are the 5 elements of measuring system, and these 5 elements are factors affecting the calibration standards, factors affecting the workpiece, factors affecting the inherent characteristic of the instrument, factors affecting the person who carries out the measurement, and factors affecting the environment. So these are the factors which affect the accuracy of the measuring instrument. Now, let us talk one by one each of these factors. Factors affecting the standard, it may be affected by coefficient of thermal expansion, calibration internal, stability, elastic properties, and geometrical capabilities of the instrument. The instrument, since it will be made of some material, it will have its own thermal expansion. Now, its accuracy will be affected by the thermal expansion of the material, stability, elastic properties, geometrical capabilities, etc., etc. Moving forward, the second factor may be factors affecting the workpiece. These are cleanliness, surface finish, surface defects, etc., elastic properties, right? So always remember that whenever we have to measure any product, that product should be very clean, it should have very good surface finish, and it should be free from surface defects. Now, let us talk about the third characteristic which affect an instrument, that is the factors affecting the inherent characteristic of an instrument. These are scale error, effect of friction, hysteresis, zero drift, calibration error, repeatability and readability, constant geometry for both workpiece and standard. So these are the things which affect the inherent characteristic of the instrument. And talking about the fourth factor is factors affecting the person, and those factors are training skill, that is the person should be a skilled one, ability to select measuring instruments and standard, of course if he has a good knowledge of those instruments and their working principle, then he can select those measuring instruments, and his own attitude towards personal accuracy achievement. So that was fourth factor. And when you talk about the fifth factor, the factors which affect the fifth element, that is the environment, are temperature, humidity, surrounding, thermal expansion from due to heat radiations from lights, heating elements, sunlight and people. Now remember, all these factors are discussed with respect to the elements of the measurements, that is the standard workpiece, instrument, person and environment. These all elements of measurement process are affected by certain factors. So let us stop here and we'll discuss some few more terminologies in the coming lectures. Till then, thank you.